All right. Well, snow day. I guess that's what we get for splitting up the lecture over two different lectures. So I'm doing this at home, so forgive any kind of weird background noise that you might hear. Um, but anyway, I wanted to get in and actually cover what we didn't get to cover on Tuesday, and we'll start out with gzip and bzip and tar. Which I guess I was going to front load all the hard stuff for you real quick. Gzip, well, tar in general tends to be one of the more difficult ones because I think as far as commands go, they're probably the most complex. You have to add the most options to them, so you have to think about them the most. The other stuff, not so much. We'll dive into that here in just a minute. So let's get started. On my VM, I want to get at least one text file that I don't have to write myself because that would take too long. Moved over real quick so that we can start to play with it just a little bit. So I'm going to copy out a file from sources.list. So this is one of the files that you can get from the Etsy app directory. This is a file that contains all of the different repositories. So this is where all of the software on the internet lives whenever you go do your updates for Ubuntu, or you could do this in Red Hat and OpenSUSE as well. But you grab this file, and this is the file that will tell Ubuntu where to go to get its updates. So I'm going to copy that to here. So we talked a little bit about how to go back a directory earlier. In the past lecture, you do cd space dot dot, and that is, the dot dot is a shortcut for the directory on top of this one, the one before it, the one I came from, essentially. And dot is a shorthand notation for right here. So you'll have to take a look at my prompt there, and you can see that little, right after the colon, it tells you where you are. And that squiggly is that shorthand for my home folder. So I'm in /home/Leo. So that dot basically represents /home/Leo. So I'm doing a copy from Etsy app sources.list, that particular file, and I'm copying it to here, right here, my home folder. So when I do that, I can do a long listing real quick. This is why I wanted to get a file. I don't have anything else in here. This is pretty much it. So that's the only file I got, sources.list. Let's look at it with cat. A lot of stuff, right? Not a lot of that's going to make a lot of sense, at least not right now. And most of it's comments. Any line inside of a configuration file or a script or anything like that that is Linux centric, if it has pound sign or that the sharp sign or the hash mark or what octothorpe, whatever you want to call it, that thing at the front, doesn't matter how many there are. If there's one or more, it is a comment. So the vast majority of this file is actually a comment. Anyhow, a little further down, you see deb http. Those are the actual locations of where the software lives. So, anyhow, I just wanted to show you that. That's what we're dealing with right now. So I'm gonna long list it again, and I want you to see about how big this is. So, I guess you can add an H if you want to see. Yeah. So 2799 bytes. If you do the human readable like we did with free earlier, you can see that it's 2.8 kilobytes. Anyhow, not very big, right? I mean, it's just text. There's really nothing to it. But when you think of log files, for instance, when you have one of those, a log file will continuously get bigger and bigger and bigger and bigger and bigger. So you kind of start to see where the requirement for zipping things up is, and that's really where this conversation will start. So a bit of a history lesson. Tar is usable by itself. You don't have to actually use it with any kind of compression or anything like that. You can just tar up a archive, which is a directory, or anything, right? You can put anything in essentially what becomes a folder. But it's not a normal folder, right? It is an archive. And what that means is the T in tar stands for tape. So tape archive. What this means is that you're able to actually put this archive on tape, like actual tape. So you can kind of think those reel-to-reel tapes where, like back in the 70s and 80s, they would do audio recording and it would be on those reel-to-reel tapes, those little circle things, and they would roll, right? Tape archives are very similar. You can look at a tape drive and see what I'm talking about. let's see if I can get one. Yeah, one of those, right? And the tapes are about as big as an 8-track. If you're old enough to remember what an 8-track is, that's about how big they are. Now, so think of a floppy, maybe a slight amount, a bit bigger, but certainly probably about an inch or so thick. And anyway, these things contained what you would expect to see in a tape, right? Like that magnetic tape, reel to reel. Well, there's just one reel in this one. But it's a reel of tape, magnetic tape that stores ones and zeros. That's exactly what it does. And we needed a solution back in the day, back in the 70s and 80s, for how to actually store data sequentially on one of these things. The upshot is that tape is super cheap and really dense. I mean, you can buy like 6 terabyte tapes for a fraction of what a 6 terabyte hard drive would be. The downside of that, though, is that tapes are sequential. The whole reason why we have tar as a software is because tapes require data to be written sequentially so that it could be read back to you in a sequential order, whether that be reverse or forward, doesn't matter. You needed to read it from front to back or back to front, and there was no in between, right? Think of, if you're old enough to remember tapes, right? You had to fast forward, and you just kind of guessed where the song ended, and you did it a bunch of times, you can kind of figure it out. But tapes don't work like that. There's no CD skipping, right? You can't skip a track on a tape. Not until way later, but even then, that wasn't perfect. So anyhow, the advent of tar, right? It became extremely important for us to be able to write data sequentially. So that's where tar is. But tar has come a long way since the 70s and 80s, and one of the things that it gained was the ability to zip things as well. So that's where gzip and bzip and xzip and a bunch of other different types of formats come from. But gzip and bzip tend to be the most popular. So those are going to be the ones that we deal with the most, and what we're going to look at right now. So anyway, tar. You can create a tar archive out of any folder you want to. So you can actually do this if you'd like. Obviously swap my name for your name in your given example. But so let's back out one. You can see I'm just in the home directory, and I've got Leo inside of it. One of the things that we can do is obviously tar. And you can look at my example here. Create, that's C, out of this file. So you're creating an archive, creating a tape archive out of this file. So that F says, here comes a file. This is what I want to create. This is the tar archive I want to create, and out of this thing right here. So you always give the resulting file first. So tar, create this file. So this will be Leo's home.tar out of home Leo. Oh, permission denied. So sudo. Notice that second line, home.tar cannot open, permission denied. And the reason it's like that is because of where I'm actually writing it. I should be writing it somewhere else. So I can do it in temp, and then I won't require sudo. So /tmp. Let's do that again. Try that again. There we go. Okay, that works. I was going to use sudo, but might as well just use it like it's supposed to be. So in temp, there is now a leos-home.tar file, and I made that out of home.leo. Now, that doesn't change anything about the current set of files that you were worried about, right? So, I mean, I can go back into my home folder. I can see that the file is still in there. None of that stuff actually changed, but if I ls temp, you'll see now there's a leo-home.tar file. And, yeah. So, it's got some stuff in it. It's got more stuff in it than... let me see, tar t, tmp, leos, home.tar. Oh, we'll come back to that here in just a minute. So, so anyhow, the idea is that we just created an archive out of that home folder. So, the thing that we got to, we got to the point where tapes are, especially dense, but they are not infinitely dense. So we got to the point where we needed to zip stuff up. So I want to play with just the zip stuff by itself for just a minute so you can see how it works by itself, but know that typically you won't be zipping up a single file a lot of the time. A lot of the times you're going to be creating that archive first and then zipping that up. So just to show you, you can, I'm in my home folder again, with that sources.list file. You can gzip sources.list. And let's look at it again. So that's one of the things that happens when you actually gzip a file by itself, is that it takes that file, it zips it up, and then removes the original file. So the original file is now the zipped version of that file. So you don't get, like tar, where it doesn't remove the original file, it creates a copy. Gzip will use the original copy to become the zip file. So you got to be careful with that. So know that will happen, but take a look at the sizes of that. So before it was 2799 bytes, now it's 730 bytes. So we're looking at 74028. It's almost a 75% reduction in file size. So I mean, you can see why this is important. You know, you turn that 6 terabyte drive, 6 terabyte tape drive, from, you know, just 6 terabytes of raw data to, if you were compressing and if it was giving you a 75% return on that, you know, you'd be able to store 24 terabytes worth of stuff, as long as that stuff is zipped. So anyhow, the reverse of that is g unzip. So gzip and then g unzip. You can do sources.list.gz. Cool. Then you look at it again, and it's the original file again at the original size. So the important thing about compression, though, is that if it doesn't return back to the exact original size, you've broken something. So it's got to be exactly the same. So you can do the same thing with bzip2, which is the other option if you look here. So I've got gzip and bzip2. Those are actually the commands. So you can do bzip2 sources.list, and then we'll see what the resulting file is. Notice, though, that bz2 is the file extension, and that it's not quite as good as gzip in this context. So the reason that we have two competing standards is that gzip is really good at doing text, and bzip is really good at doing binaries. And you have to kind of figure out which one it is that you want to take in your particular instance. Now, there was kind of a meeting of the minds in the middle with gzip and bzip, and there was, you know, for lack of a better word, there was like a war of the compression algorithms. And to be honest with you, they're really good in their own respects, but gzip won. So you will more likely, more often than not, find a gzip than a bz2. So just be aware that bzip2 is a thing, but whatever files you're getting, you're probably going to be a gzip file rather than a bzip file. So anyhow, we'll keep moving on, and let's bunzip this thing. Oops. Oh, bunzip2. Bunzip2. It just makes it really difficult to type, so it's no wonder that gzip won. It's just so much easier to write. Anyway, so to do an entire archive, you saw how I did that. So tar cf. The only thing that you would change differently to make this a gzipped tar archive is to add a z option. So I've got that written here. Z for gzip, J for bzip, if that's what you want. So an example would be tar czf. So the only difference between the example I did before is that I added z. So let's do that real quick. See where I'm at. I'm in my home folder. I'm looking at Leo. So tar, instead of cf, let's do czf. And the resulting file I want is temp sources.list.tar.gz. Now you kind of have to decide what this file is gonna look like in terms of file name. So make sure you're typing something that, you know, has a .gz on the end, so you know that it's actually gzipped. Otherwise, you can still figure it out, right? I mean, the file command will tell you what it is, but it's just easier on the eyes if you add in that information. And then we're making that out of home Leo. So create that out, and then let's do the same thing though, but with, instead of z, let's do j, and let's change our extension to bz2. And then let's lsl the temp directory. And now you can see leos-home.tar, sources.list.tar.bz2, and oh, you know what? I just realized. I typed in sources.list.tar. What I should have done, here, let me just do this. Remove tmp, sources.list.tar. Let's do bz and gz. Let's get rid of those two files. Let me just rerun those commands real quick. That way there's no confusion about what's going on. Leo's home is what it should be. Let's do that. Find my other one. And I'm using the arrow keys to go back through my history. Oop. I said history, not typed history. Leo's home, tar BZ2. Okay. Now let's look at that one more time. So TMP. There we go. So now we got leos-home.tar, .tar.bz2, and .tar.gz. So, I mean, we're talking a difference of 69 bytes between the BZ2 and the GZ. So it's not like, it's not like you're going to break the bank, right, in either of those situations. But coming from the tar without any compression, I mean, we're looking at even better than a 75% compression rate. I mean, we're looking at something like 80, 85%. Yeah, from 20 kilobytes down to 3. We're talking a very good compression rate on stuff like that. So when you're just talking about text, you want to compress it. Text is very compressible. Executables, not so much. Binaries, things like that, not so much. But you still do it anyway. That way you can ship someone one file in a GZ file. You know, you might have a couple binaries or something like that, but even though they don't compress right, you'll save a couple of bytes. And then that GZ file will contain all the junk inside of it, so you only have to send someone one file. All right, so that's pretty good on that. Now, here's one of the cool things that you can do. So let me remove those files one more time. Temp Leo's home tar.b and temp Leo's home tar.gz. Now, here's one of the cool things that you can do. And these will all apply, right? So this semicolon basically takes one command, runs it, and the semicolon says, all right, here comes another command, and then you run that one as well. So it does not matter. Whether the first command fails or succeeds or doesn't matter, it will run both commands. This is pretty much just a, comma in speech. You just keep talking. And you can do this, right? You can do this with as many commands as you want to, just back to back to back to back to back. Now, this works in a very similar way, and I'll give you some examples of these in a sec. And this is one of them where you can run the update of the cache and then upgrade all the software packages afterward. But anyway, and basically says that if the first command succeeds, then run the next command. But if the first command does not succeed, do not run the second command. Now, this is pretty important, right? So, I mean, take a look. In this particular instance, it actually makes a lot of sense. So, apt-get update, that will update the cache of your software. You know, if there are new versions of the software, it'll be like, hey, there's 20 updates for you to do, and then you would then run apt-get upgrade. Now, and is probably the correct choice here in most cases, because if apt-get update doesn't work, then there probably isn't going to be anything to upgrade because you weren't able to get out to the internet and figure out what was new, or for whatever reason, right? It's not going to be useful for us to go and update software if we didn't get the updated list of software. So if that first one fails, do not do the second one. That's the idea. But if it succeeds, then obviously do the second one. This can be automated a little further if you just add the -y. Oh, I think it goes on the side actually. -y, and that will answer yes to any questions. So if you remember when you do apt update, apt upgrade, then it asks you, are you sure you want to do this? You can pre-say yes if you just add that option. Now, this one is the opposite. So you're saying apt-get update, and if that fails, then run this command. So it's the opposite of the and. It just does, if it fails, do that. That is actually pretty important. This is one of the things that we can run every hour, and we can mail root. So you're sending the root user on the system, who is the super user, the administrator, on the system, a message of update broke. And then we can go and investigate, right? I mean, because that is not a good thing. If we can't touch the sources.list that we were looking at before, if we can't touch the places that exist in that file, then there really is something wrong. We don't have internet, or those the repositories are down, or something, right? Something is not good. Something is not good at all. So we want to mail root. And you can actually do that. Anytime you get a message to root, you can actually forward that out to a real email address. That way, anytime you get an error message on one of these servers, you can actually get an email on your real device. And, within just a minute or so, you'll know that something's wrong. However, right, I mean, if internet's dead, you're not going to get that email because you kind of have to have internet for email. But anyway, you can email it to your logging server that may be on the same network segment, which means you don't need internet. You just need network connectivity, local network connectivity. So there's a few things that you can do with this to make your life a little bit easier. But I just wanted to show you. So if we wanted to create two archives at the same time, we can do that. So notice I've got tar-cjf creating that same archive. You can do the same thing, right? Semicolon tar czf temp leo's home.tar.gz out of home leo. You can do them both. And then if we lsl temp, you can see they both exist. Right? So just really cool, simple things that you can do. And for some reason, you can swap that one in there if you don't want the second archive created. If the first one's not created correctly, you can do that one. Or, you can do it where, again, if the first one fails, then the second one will succeed, or you hope it does. That's kind of the idea, right? You can add those in there. T is really cool. T is a command basically that will allow you to take one stream of information, right? So you have this, right? So you've got standard output coming back to you, right? Well, let's say that we want to lsl tmp, just kind of get a snapshot of what's in the temporary directory, and you want it to t. Let's call this t temp snapshot. So lsl/tmp, and when you see just one of those pipes, this is not this. When you see one of these pipes, that is saying redirect that output to this new thing. So ls-l/tmp. Normally what would happen is you would just get the output like I did just a second ago. But with this pipe, I'm saying, all right, send that output to this particular thing. And in this case, we're sending it to the command T, and then we're giving a file name of tmp-snapshot. Now, T is special. T will do two things. It will take what you gave it, so the LSL, it'll take that, and it will redirect it into tmp-snapshot. So you'll have a file named tmp-snapshot at the end of this, and it will contain the information that you just that would normally have been output. But T then takes that one step further. The second thing that T does is it also outputs it. So if you take a look at that, right, that's the output minus all the cool colors. And let's do an LSL. Oh, wait, that actually wouldn't have worked. Yep, I got a permission done because I was in the wrong folder. I need to be in my home folder. So let's try that again real quick. All right, do that again. I will create that file this time. I won't get a permission denied. Notice it's right underneath that command. It says permission denied. That's why that didn't work. I was just in the wrong spot. So you go there. There it is. tmp-snapshot. That exists. And if we do a cat on that file, then take a look. That's what's in that file. It's really hard to read because there's not a lot of colors. But just keep an eye on that. That's the idea. T will take it and create a file out of it, and then it will also put it out onto your screen. That's the short and skinny of what T does. But T typically isn't used by itself. T always takes output from something else and then splits it, right? One into a file, one onto the screen. The alternative would be just redirecting that to TMP snapshot 2, like that. So that would work as well, right? But now we have 2. But notice, right as I redirected that, I didn't get anything on the screen. So that's the beauty of T. T will do the same thing as this redirect I just did, but it will also put it out onto the screen. And so especially when you're dealing with log files or whatever, you don't want to create the log file and then go look at the log file. You want to create it and look at it all at the same time, and that's where T is going to come in handy. All right, so we're looking at a few different things. A lot of times you don't really deal with text management on the command line much anymore, but it's still pretty useful to be able to do stuff like this. So sort is a pretty cool thing that will basically alphabetically sort any line in a file uh, oh yeah, take a look at this. So in this example, I have it to where it's the K2 is saying the second column. Take the second column of every single one of these things and sort by that alphabetically. So you can also give it the -n option if you want it to be numerically, but there's oh right, yeah, if you want it to be numerically. So anyway, what we can do is sort sources.list. So look, take a look at that. Basically what you're looking at is it ignored all of the hash marks, but it starts up at the very top, starts with A also, D, Deb, and then every single one of these, look, it is alphabetical. So that very first Deb line without the hash mark, if you keep going all the way over, it's Bionic-backports, B. And then using that same line, you see M, SSS, U. So it has taken that and alphabetically sorted it. If you wanted it to be with the second column, you could do this K2, third column, K3, fourth column, K4. Sort has a ton of different options that you can use. And I don't need you to know, a lot of these really at all. I just need you to know what sort does, to be honest. But just kind of be aware that sort can do this kind of thing for you, and if you want it to, you can redirect that out, right? So sort sources.list, and then you can redirect it alphabetical sources.list, right? And so you have your original sources.list, but now you have an alphabetical sources.list. So if you cat alphabetical sources.list, you'll see what sort did to sources. So this is why this stuff is so unique. And so cool, I think, because each of these tools does one thing, and they do it very, very well. And that is, you're going to see on the internet, if you ever go digging around for tools that do all these things or whatever, you're going to see a lot of people that are arguing against doing that, because the Unix way is to do one thing and one thing well. So a lot of times you will see people push back on, you don't need a program that does sorting and number lining all in the same thing, because we have sort and NL. So those exist by themselves, and what you're supposed to do is string those together. So let me show you what I mean by that. So NL basically does something similar to sort, but it will just number line everything. So if you do NL sources.list, it's the same exact file that you had before, but it just puts a number at the beginning of every single one of these lines, and that can be very useful. But here's the deal. What you can do at this point then is sort and then give that output to NL, and then redirect that output to alphabetical. Well, here, actually, let's not do it to alphabetical. Let's do it to num alpha sources.list. So it's numerically sorted, or it's everything has a number line, but it's alphabetically sorted version of sources.list. So you can do this kind of thing, right? Okay, so what's happened here is sort sources.list. We have sorted it alphabetically, and then we have given that output to NL. So it's alphabetically sorted, and then after it's alphabetically sorted, we've stuck a number at the beginning of every line. So let's look at num alpha sources.list, and then you can take a look at that, right? So it's kind of a merger of sorting that file and then number listing that file, but we all did it in one thing. And so again, this is the Unix way, right? You don't need a thing that sorts and numbers. You just need the two tools individually, and you smack them together doing command line foo like that. And here's the cool thing about that is that you can keep going with it, right? So you can T that out, right? And you'll end up with the same file. It might actually break because there's already a file named that, but it may just override it. So we'll actually, it will override it because of what I've done. That single redirector, that little right arrow, if there's one of them, it'll just overwrite whatever it is. So you've got this new file, or you're gonna have this new file, and T is gonna give us more output. So I can just give that output to, and then we can do WC. And now WC will give me a word count on all that. But it's kind of broken, mostly because of all of the weird formatting that we've done to it. But I mean, it still works. The idea is that it still would work. And I think what I'm really trying to get at, and we'll kind of keep our place here, is that a little further down, I get into this idea you're able to take one command and then pipe it to another command and then pipe that to another command and then pipe that to another command and pipe that to another command, pipe that to another command, and you get, some a very edited output. You don't necessarily always have to make files out of this or something like that. A lot of times what people will do is just, I need to see this very specific thing out of these couple of files, but I only want the first 5 lines of these things, and so we're going to play with it a little bit and use these tools to kind of give you exactly what it is that you want. So anyway, a lot of times you just got to play with it a little bit, and then it'll work. So anyhow, that's the deal. You can stick all of those together, and I see what happened. I think sticking T in there is what really broke it, because it redirected to a file named T. That's exactly what happened. Okay, so anyway, so number line, move that into, and then we do well, we can't do a word count on that. We would have to pipe that out and see that. So anyhow, that's the deal. Looking at a little further, you can use cut. So this is basically just looking at the first 25 letters of a file. So you're cutting characters 1 through 25 in the Etsy FSTab file. So we can do that in pretty much any file, really. So you can do cut characters 1 through 10 of sources.list, right? And that's on every line. It'll do that to every single line. So it only gave you the first 10 lines of that. You can bump that up to 20. You can bump that up to 30. And you get larger and larger bits of that every single time. So a lot of times, cut can be very useful when you have rows of information. You find out the longest row, and then columns of information. You find columns of information, and you find the longest column is 25 characters. So then you just say 1 through 25, and then you just get that one column. So cut can be pretty useful for stuff like that. Some of these I'm gonna go through a little quickly because we're not gonna use them a whole lot. But paste. If you want to see the two files joined together, you just want to see one after the other, after the other, after the other, you can do paste with that. So you'll see names and then cities and then addresses. If those files existed wherever you were, you can just write paste, all of that. Join is similar, but you can only do 2 files at a time. But join, one of the cool things about join is that you have, let's say you have 2 files of lists of cities, right? And you see Abilene in there a couple times. You see Abilene in both files. You see Sweetwater in both files. You see Brownwood in both files. But, one file has Dallas and the other one has Houston. So in that case, you do join, and you basically have the difference of the two. So you'll get, you will never get duplicates, put it that way. Join does the same thing as paste, but it removes duplicates. So you will only see Abilene one time. You will only see Brownwood one time. Head is pretty cool. A lot of times you want to look at logs, or at least the very top of a configuration file or something like that. You just want to see some of the basics. You can just write head and then the file, and that'll give you the first 10 lines. That is, let me clear that. Let's do that one more time. It'll give you the first 10 lines, which is usually pretty informative if you're just looking to see what a file is or what it's about. And you don't want to see the whole thing, right? You don't want to have to use less, or you don't want to have to do cat, so you just get a whole, terminal vomit of all kinds of stuff on there. And then tail is very similar to that, but it does the tail of the file, the very bottom of the file. Tail is really useful for when you're looking at logs and you only want to see what just happened. But sometimes in these, you see too much. So I'm like, I want less. Give me 5 lines. Or I want more. Give me 50 lines. All right, the last 50 lines. And the cool thing about head is that it does the same exact thing. Oops. You can deal with it in the same way. In that that'll give me the top 20 lines of that particular file. So head and tail, pretty cool, especially with logging. Now sed is pretty interesting. So sed is basically a way to take some text and change it to other text. And it's like if you ever saw find and replace in any text editor, right? I mean, you got tools up here. I'm pretty sure find and replace is in here somewhere. I'm sure it is, but maybe. It's in there somewhere. Anyhow, find and replace is totally a thing, right? You tell it, find every word lowercase the and turn it into a capital T the. You can do that. And then, so in this particular example I've got right here, said, the input file or the input word is yes, and the output word is no, and then in the questionnaire.txt file. So what you're looking at is basically you're changing everybody's answer from yes to no. That is what's happening right there. So probably not good for voting, but definitely good if you want, if you're asking a question like, hey, was service horrible today? And then you just, say yes. Or if anybody that said yes, you just swap it up to no real quick. No big deal, right? Service was great today. So in our particular example, I'm going to use, let's just do a copy sources.list to sources.list edited. And then let's do sed s. I want to change deb to rpm g, and then of the sources.list.edited. Take a look at that. So now where it would normally have said deb http:/deb-source, it now says rpm. So just an interesting way to do more text manipulation, things like that. But you can then take that and then redirect it out to the sources.list.edited file. And now sources.list.edited now actually contains that RPM stuff. So grep is pretty interesting as well. Grep is basically search. That's exactly what it does. But it can do a few different things. It can do some really unique searches. And one of those is looking for the word RPM in the sources.list.edited file. Oop, what? Hang on. Let's see. What ended up in there? Oh, how funny. It didn't redirect in there. Well, let's look at something real quick. Oh, how funny. It sure didn't. Well, let's try it with this one. Let's just try it with the sources.list file. And instead of looking for deb, we'll look for rpm. Grep deb sources.list. And so you can see that anything highlighted in red will be... Anything highlighted in red is basically what grep found for you. So it'll give you the whole entire line. So you can do that with a bunch of different stuff, right? So let's look at lscpu. I know that I have an Intel processor, so we can do grep. Oh, here. This one's going to be a little bit different. But it's going to show you how you can use grep to accept information. So you see that lscpu will give you out all of that information. We want to redirect that. We don't want that on our terminal. We want that to go into, let's grep for Intel. And then it'll give you, it found genuine Intel Core i5-5300U. And the speed. And then you can do that with pretty much anything, really. Any particular command that you want to deal with, free, if you just want to see mem or something like that. And you don't know the options for that, you're better with grep or something like that, you can use that to deal with. But you can do that with files as we did before. You can just do grep, what you're searching for, and then the name of the file, and that will work as well. So a couple of different things. Oh yeah, right here, dmessage. This is actually pretty important. This one I ended up using a whole lot. And you're looking for messages with the word failed in it. And sometimes it's at the beginning, or capital F. Right, and so that's one of the things you can do is ignore case. So if you do grep, well, here, let's do dmessage, grep-I, and look for the word failed, we get all three. So notice, before I did grep failed, and that was a lowercase failed, grep capital F failed, and it only find capital F fails, and then -I gave me all three. So it's uppercase, lowercase, doesn't matter. -I means case insensitive. I don't care. If it's an F, it's an F. It doesn't matter to me. So that's a pretty useful thing to do. And then grep-E right here is basically looking for a list of things. right? You wrap it up in a quote, a single quote, and well, actually you can use double quotes as well, but a quote and then a parenthesis, and then split out each of the things that you want with one of these pipes, and then Etsy password as well, or looking for that thing in Etsy password. That will be, so what this is doing is basically looking for the word bash, C shell, Z shell in the Etsy password file. -E. So -E, it says, here comes a list, grep. Look for all of these things. And then -F is pretty similar, except instead of giving it the list altogether, there is a list of words in this file that we want to search Etsy password for. So grep is pretty useful. Definitely when you want to find stuff, grep is going to be your savior on that. So we were searching for bash a little while ago, and bash is actually one of the most popular shells. And shell is this, right? This text interface that we have with the system. Bash is the most popular. It comes stock on pretty much every single distribution that you can get your hands on, in OpenSUSE, in Red Hat, in CentOS, in Ubuntu, in Fedora, in Debian, everything. Everything ships with bash. There are other options. You can change whatever it is that you want to a different shell, right? I mean, there's C shell, there's Z shell, there's fish shell, there's all kinds of stuff. But by default, everything is bash. So the most important shell for you to understand how to use is bash. And the way that that basically works is it's listed for you in, well, the reason that we know that it's bash is in the cat etsy passwd file. This is a file that contains every single one of the users that exist on the system, and that very last option. So look underneath root. So, well, here, let's just look at the very last line, right above the prompt. It says Leo X 1000 1000 Leo Chavez, and then home Leo, and then bin bash. So we can look at that. That very last thing shows bin bash. That is my shell. If I wanted to change that, I could do that with the usermod command, but that's a conversation for another day. But you can change that using usermod. But this is how we know that you actually do have a login, and you do have a shell that you'll get when you log in, and this is the one that you get. So bin bash is what I'm using. And overall, I'm probably the only user besides root that actually has a login. Everything else has been false, or you can see in the file no login, user sbin no login. And what those means is you can't log in with these accounts. Those are service accounts only. And one of the things that we talked about last time is that you can echo. And again, this is kind of not something that you need to be totally familiar with just yet, but you can look at this variable called path and see what's in your path. So these are the things that I can do which on. Let's see. Outside of that, bash behaves specific ways on specific distributions. Now, I mentioned before that everybody uses bash, but everybody has bash customization. So things like LL, here, let's go in here, work in Linux or in Ubuntu, but they may not work in OpenSUSE or CentOS. Now, I don't have either of those VMs on this laptop because I'm doing this from home, but the idea is that these aliases, these things don't always exist in every distribution, but they're defined in one of these three files. And these files are read in order. So Etsy profile is where you go to set up global settings for bash. So you want bash to behave in a specific way, you want it to have the alias of LL or something like that, you'll go add it to that file in Etsy profile. And you can see, this is a script. I don't expect you guys to be able to parse this just yet, but the idea with this is it's basically assigning a few variables, kind of giving you an idea. This is defining what your prompt looks like, telling where else to look, bash.bashrc. And you can see there's a bashrc in here. So Ubuntu actually has an additional one here in etsy bash.bashrc. And then etsy profile.d. Anything in those files, anything in those directories of those files will be added onto this. But that is part of this Etsy profile file, so it doesn't necessarily need to be written out. So There's also bash profile. So let's do LL. We don't have a bash profile in here. We have a, let me see, we have a bash RC. So that's this one. You might find bash profile on OpenSUSE and Red Hat or on CentOS. But in Ubuntu, it's bash RC. So if we want custom level stuff, like my user wants these specific changes, but that doesn't affect all the other users, I can go into bash RC, .bash RC, and make those changes. Now again, you don't have to know how to edit these files because this is all scripting. And I just need you to know that these things exist. And the idea with that is if you look up very top of this, very top of the VM, you can see alias fgrep equals fgrep -- color equals auto. So one of the cool things about this is that you define these aliases, and every time you type in fgrep, it actually does fgrep -- color equals auto. So and this also happens with ls. Look down a little further. You can see some aliases for ls. So you see alias ll, alias la, and alias l. So we can also do l, just a single l. It'll actually work. And ll, that'll work, and la, that'll work. But those aren't commands by themselves. They actually just point to ls, a very a configured version of ls. Look at the top. You can see ll actually means ls-al capital F. LA is actually ls-capital A, and L is actually ls-capital C capital F. So that's where some of these things are configured. And if you want to add your own, you can. So one of the cool things that that you can do is, well, I guess anytime you want to make any kind of changes, really. Well, actually, we cover alias in a further chapter, so I'll actually cover it a whole lot more in depth there. But just know that these files right here, these top three, contain what kind of customization for Bash you're going to have when you log in. And I think in Ubuntu you also have .profile. Yeah. So we'll add that one in there. But know that not all these files exist on all these systems, on all the systems. And then when you log out or exit the shell, these scripts are run. Now, let's see if we even have one. We should. Oops. LSLA. Yeah, .bash _ logout. So let's see what's in that real quick. And really not a whole lot. What it does, when you leave the screen, it just clears the entire screen. That's basically all it does. Cool. Anyhow, so we talked about that. One of the other cool things that you can do with this is if you have, let's say you have that command, right? You can actually break that out with these backslashes. A backslash is an escape character that says, here comes another line. And so if you end a command, if you just type that in, right, rpm-ql package, blah, blah, blah. So like you're querying that package or something, but you want to do more to it. You do a backslash and you just hit enter. And then the prompt is going to come back and ask you, all right, what else? And then so you tell it, do another slash, and then you tell it, do another slash, tell it, do another slash, tell it, do another slash, tell it, and then hit enter. Once you stop adding that slash at the end, it'll finally execute that entire line of commands. But this is no different than this. Same exact thing. This requires more work, but it makes it way easier to read. All right. So these are some of the other things that you're going to run into, right? We talked about the tilde. That is just the shorthand for a home folder. Your home folder, not just any home folder, your home folder. The backslash, ignore the next character. That's why we were able to do this right here, right? Ignore the next character, which is enter. So it ignored that. The / is directory separator. So, you know, you've seen that a million times. /etc/ whatever. Dollar is, or dollar symbol, precedes any variable. So we saw that variable before. So you know this is a variable because it starts with a $sign. So I'm basically saying, hey, terminal, tell me everything about variable path. And then it says, well, here's what's in variable path. So a variable contains more than just path. It contains all of your paths. A single character wildcard. So we're going to get into this a little bit more as well. But if you wanted to do, let me see. There's really not a good example of any file that I've got in there right now. But basically, if you know that you have a TAT and a TXT type file that you want, this will list every single one. So that asterisk wildcard here basically just says whatever, anything. So let me show you what that actually does. That one will be easier. LSL, and we'll start. Give me every file, list out every file that starts with the letter S. I don't care what comes after, it doesn't matter at all. And so it'll show me sources.list and sources.list.edited. So you can do that again with the T, and it'll give me T and temp snapshot and temp snapshot 2, right? And you can put that anywhere, right? Like, so just show me everything with the number 2 at the end of it. And just, again, just anything at all. So anything that has a period in the middle, I don't care what comes to the left of the period, I don't care what comes after the period, just show me all the things with a period in the middle and stuff to the left and the right. Right, so you can play with that a lot and get a lot of that. And then question mark is the same as the asterisk wildcard. It just does one letter, right? So if I had let's do that, right? So show me everything that has that starts with the letter S, but then only has one other character. I don't care what that character is. It'll show me all of those. Right, but that doesn't work if you add a third thing, right? It doesn't know what you're talking about because there is no file in here that starts with the letter S but then has 2 characters after it. But if you swap that to a T, then yeah, there's a file in there called TEE, and that actually matches that that wildcard, or not the the single character wildcard. And then so absolute quotation mark basically. You can use either the single or the double quote, pretty much interchangeably and just about every single time. But there is a definition for why you want to use one or the other. However, it's not important to us, so we won't worry about it too much. Now, this little backtick. So this thing is the thing. So look at the tilde key on your keyboard. It's the other thing. It's not the tilde. It's the other thing that's on that button. If you just hit it without hitting shift, that's it. So you can do date, right? And then echo date. But if you want echo to actually come back with date, you'll have to put it in backtick. So that doesn't seem too useful now, but as we get into scripting and a little more complex stuff, command substitution actually turns out to be really, really useful. We can actually do this. We can actually use this date thing to, every time we want to back up a specific file or folder, we want to snap a date to the back of it. We'll end up using command substitution to do that. That way, we'll know exactly when that file was created, regardless of how many times it's actually been touched. So that turns out to be pretty interesting as well. So we've done both of these ampersands, right? If you do Firefox and it'll run Firefox, but push it to the background and give your terminal back. If you do a double ampersand, that is basically running one command. Only if it succeeds, run the second command. Pipe, we've used that a few times today. So give this output to another command. The double pipe is if the first command fails, then do that command, then do the next command. This one doesn't care; it just runs these commands one after the other after the other. Then, if you want to look for, files 0 through 9, so, say you had, file 1, file 2, file 3, file 4, file 5, 6, 7, 8, and 9, this would list out all those files if you wanted. Or you can do, 0 to 5 just to see the first 6 or something like that. And then we saw redirects, and then redirect the other way. A lot of times that isn't too terribly useful, but if you have, arguments to a command or something like that you just want to feed into that command, you can do it like that. So anyhow, this is not used nearly as much, but let's say you had a list of files that you wanted to remove, and you just had a list of that. You could do rm and then feed that list of files to remove, right? And then you could feed that into rm, and then rm would dutifully go through the list of the files, and it would delete every single one of those, and it would complain about any of the files that it didn't actually know where they were. So anyway, you can do that kind of thing as well. However, it's pretty far and few where you actually do that. Anyway, so while working in Bash, you're going to see a ton of path names. You're going to see a ton. And if you've noticed, I haven't actually been typing pretty much everything. I have typed in, commands or whatever. But if I wanted to actually read a file, I would do num and then hit tab, right? Do not forget about your tab key. Your fingers are going to thank you. Your sanity will thank you because you'll typo less. If tab doesn't work, it means the terminal doesn't know what you're talking about. So you already typoed somewhere, or you're not in the right spot to be invoking that file. So tab serves a multitude of purposes, only one of which is making it easier on yourself so you type less. But I use tab most of the time during a command to actually check myself to make sure I haven't typoed already. And then on top of that, it's actually making sure that that I'm in the right spot, or that my head's on straight, essentially, right? Like if you're doing a tar command and you got the things backwards, it's not going to autocomplete for you. So it will help keep you on the rails. So use tab a lot. Tab, 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 all the time. Tab everything. Tab it, tab it, tab it. If you're ever in question, tab it. Tab it every single time. All right, so the last thing that I want to talk to you guys about real quick, and then we'll be done with all of this, is you can actually use the set command. I need to fix that real quick. The set command is actually a way to configure bash on the fly. So we had talked about how you have etc profile and home folder dot profile and all those things where you can edit bash. Well, sometimes you just want to make a change real quick, and then you don't want it necessarily to be saved every single time. So I mean, these will go away after a reboot a lot of times. But you can actually do things like set plus O history. So I usually think of this O right here as off. Now, this one's kind of weird, right? Because it depends on what you think O means that you can English this or not. So if O means on, this will be really confusing. But if O means off, it makes sense. So you can set the history option to off. Like we add the off bit to history. So we basically turned history off. So if you do set plus O history, then it will actually not remember your history. And history is actually kind of important because this is all the junk that I've done today. And well, I mean, it's not just today. It remembers like everything that you do. So if you want to turn that off, if you don't want your commands to be remembered or anything like that, you can run this command, set O history, and then it will not record what you're doing. This one's actually pretty interesting. So turning off or removing the off bit, which leaves it on, sets the no clobber option to on. Now, the cool thing about no clobber is that if you are redirecting a file, right? Let me see. Let's do set no clobber. What'll end up happening is you can do echo. This is some text. Redirect that out to this.txt, and then different text. It'll tell you no. So this is actually kind of a failsafe. If you're accidentally going to overwrite a file, it's going to tell you no. And only if you turn off the no clobber option will it let you do it. Because remember, that single redirect right there is actually going to clobber. That is the proper terminal Linux name for overwriting a file, clobbering. It will clobber a file and all of the contents inside of it and replace it with whatever you're doing, whatever you're telling it to do. So the way around that is you can append it like that. But the only safe way to prevent yourself from actually clobbering files is to actually turn off no clobber, or turn on no clobber. And then you won't be able to accidentally do that again. So just some really cool bash options that you can play with. The idea with all of that is that you guys are going to end up having to be really familiar with this terminal, because this class, among other classes, will contain a whole lot of Linux. So anyhow, that's pretty much the lecture. That's all she wrote. I will... yeah, sorry this is coming out so late. I mean, obviously the snow day kind of threw all the whole everything off. So watch this video and you'll be good to go. Go back and take a look at some of the options or some of the examples that I've done. That way you can kind of get a good feel for exactly how these things work. And of course, if it's not making sense, if you've already given it a good effort, You try it 4 or 5 times, doesn't work, you don't know what's going on, obviously email me, and then we'll figure it out, or hit me on Slack, whatever. All right, well, that'll be it. I'm gonna stop it here.